Welcome everyone to this episode of Manufacturing Talk Radio. I'm Tim Grady. Lou Weiss is out on assignment, so I will be working with nee'sha Irwin, who is the CEO of Solarflux. I'm actually very excited to talk about this topic. This is solar thermal energy. You don't hear it widely discussed, particularly for industry. And nee'sha, I want to really get a sense of what Solarflux does. How does it concentrate energy, bring water to its boiling point, create steam, all those exciting things that help us use the sun's energy instead of burning fossil fuels. So thank you for joining us.
Yeah, thank you so much for having me on. It's a great honor to be on your show. So as you said, I'm the CEO of Solarflux Energy Technologies. We make a parabolic dish concentrator, which you can kind of see in my background image here.
Right.
So it's a large, it looks a bit like a satellite dish. It sort of tracks the sun on two axes, and it has a very highly reflective mirror on the other side of the dish, and focuses all of the sun's energy onto a central point, as you can see in the image, and creates a lot of heat. So we'll get up to 5,000 times concentration, and the heat can get up to north of 1,500 centigrade at the receiver. So very, very high temperatures. And then what we do is we pump a fluid through the receiver. That central point, there's a coil, and a oil or a mix of water and glycol can flow through that. It will absorb all of the heat, and it transports it to a point where it can be used. And we can, with the current design, we can get up to 350 to 400 centigrade. And then we can use that heat for various processes, including industrial processes, which is a huge opportunity in terms of decarbonization and providing a sustainable energy source for industry. And that's an application we're very excited about.
Well, nee'sha, when I was a child, I used a magnifying glass to focus the sun's energy so I could, start fires over in the side yard when I wasn't observed by my parents, burning sticks.
Yeah.
How is the industry going to use this for their needs?
Yeah. So it actually works very similarly to what you just described. We're basically focusing all of the energy onto a single point. But when you think about global energy consumption, so about half of global energy is consumed as heat. And by the way, global energy consumption continues to rise. It's projected to rise by another 50% in the next 30 years out to 2050 from where it is today. So we're continuing to see growth driven by population, driven by rising living standards, increasing industrialization. So about half of that energy is consumed as heat today, and about half of the heat consumption, so about a quarter of global energy, is consumed by industry. So there's an enormous amount of our global energy footprint that is consumed by industry, and we have a real challenge as a world when we're looking to address climate change and reduce the amount of carbon and other greenhouse gases that we're emitting into the atmosphere. How do we reduce the emissions associated with that thermal footprint? And we know from the conversations that we're having with clients every week, many companies are seeking for ways to reduce their emissions footprint. Very significant and aggressive targets are being set, up to 50% reduction in the next 10 years. That kind of thing is very common to hear from our clients. So then the challenge is, okay, how do we go about reducing our footprint? What are the options available? Particularly if you have a thermal footprint. Everyone's heard of photovoltaics, but photovoltaics are not very well suited for thermal processes. I'm talking about processes like pasteurization or sterilization or cooking. These types of processes that are widely used, for example, in the food processing industry. That's where we think that we could potentially provide a very value-added solution. We have one of the advantages of our technology is it's quite space efficient, so it produces a fair amount of energy relative to competing solutions for the area that it occupies. And that's a big advantage when you have companies that have an existing plant footprint that they're trying to retrofit a sustainable solution into, and they may not have unlimited space around their plant. So that's where I think we can be, where we can add, we can be of use, is providing a flexibly deployable, pretty wide temperature range, zero emission energy source for industry, particularly where you're looking for temperatures, between say 100 C and 300 C or 350 C. That's a temperature range that we can fairly readily serve today.
nee'sha, is yours a closed loop system, so you can use the energy to raise the temperature of a fluid to 350 and then create steam to turn a turbine to capture the steam, and you don't have to reintroduce but maybe a modicum of additional water or whatever you use for the fluid, but essentially a closed loop system that's sounds like very, very energy efficient.
Correct. Yes. So we have there'll be a thermal loop that runs through the receiver and to a heat exchanger, and then that will interface with the client's existing thermal systems in most cases. And even if they need energy above the temperature range that we're currently capable of supporting, we can also provide preheating. So it'll be a simple boost to the heat as it goes into a boiler or so we just offset the amount of fossil fuels required to achieve the target temperature, at least partially. So preheating is a big opportunity, I think. But yeah, it's simply a loop that runs to a heat exchanger, and there will be a high temperature fluid, that runs through that loop, and then we just inject the heat into the client system.
Okay, so what kind of savings is the client likely to experience? It sounds to me like, because energy is a huge portion of manufacturers' cost, that they are looking at some significant savings here.
Yes. So our goal is to be cost competitive with natural gas without subsidies. That's what we're targeting. And then you have on top of that, you have elimination of price risk. So once you install the system, it's going to run for 20 to 25 years. It's a low maintenance solution, fairly simple. There should be minimal risk to having it operate over that period, and you're locking in the price for that period of time. So you gain a lot of business predictability by having a guaranteed source of energy at a fixed price for that long time period. So that's a potential advantage as a business when you're trying to plan, one of your major cost inputs, gaining that security around the price. And then the other piece is reducing your CO2 footprint. So if some companies, maybe today people aren't putting a price on carbon. In some states and geographies, there is a price on carbon. Currently in Europe, I believe it's trading at about $100 a metric ton. That's quite a lot. So we can simply offset the carbon emissions by providing the zero emission energy, and that will be another kind of effective saving to clients. So we're targeting basically being cost competitive with natural gas, reducing emissions, and providing price stability and visibility over the medium to the long term.
Now, being cost competitive with natural gas, at what point do I have an ROI so I am actually ahead of the game?
So it'll vary. It's very situation specific because we depend on the sun. So the sun is not evenly distributed, unfortunately. The Northeast it doesn't have as much sun as, say, the Southwest in the United States. So you're going to get a lot higher performance out of one of these devices in an area where there's a lot of sun. All concentrating solar power systems require clear skies to operate. Cloud cover is a problem for concentrating solar power. So it's much better suited to places like California, Arizona, Nevada, New Mexico, Utah, these types of states where you have a lot of clear days. Having said that, we can still perform well. I mean, we're based in Pennsylvania. We've got one of our units set up here in Pennsylvania. We can still perform well in the Northeast, but you'll get a much higher ROI in places like the Southwest where there's a lot more sun.
Well, because manufacturing is moving to places like Texas, Georgia, North Carolina, South Carolina, Tennessee, for all kinds of reasons, you
Yes.
seem to be a sweet spot in terms of the geographic area where this Solarflux works.
Yes, we're talking to clients in those geographies as we speak, and I think we see a lot of opportunity there. All of them face the same problem. How are they going to reduce their emissions footprint? Hopefully we're going to land sort of some projects fairly soon. We're in good conversations at the moment, and I think we're well aligned with the geographic trends in terms of where manufacturing is shifting to. Definitely.
I guess my intuition tells me that if I were to invest in this kind of technology, at some point it has paid for itself. And I am now essentially running free.
Yeah, that's correct. We just did an analysis for one client. I think we're looking at about a 5 to 7 year payback based on that particular situation. Now, it'll depend on the situation. It depends on how much sun, it depends on the price of natural gas, and what assumptions you want to put into your payback calculation. But that would probably be on the higher end. Generally, solar systems, renewable energy systems, it might be a 10-year payback, even a little bit longer than that if you're looking at it like a residential system. So they can take some time to pay back, but then you're right. Like once you paid it back, you're getting essentially free energy from that point onwards. Yes.
And certainly energy, as I mentioned, is a huge cost factor for manufacturing. So yeah. I'm glad to hear that you have developed this kind of technology. What was the genesis of this?
Yeah, great question. So my partners, so I'm the CEO and I'm kind of more on the business side. I partnered with 2 technologists who were the pioneers of the technology. It goes back about 15 years, the development project. So the lead developer, John Fangman, who's a co-founder of Solarflux and our chief technology officer, his background is all in optoelectronics and fiber optics, and he was a distinguished engineer at Bell Labs, and then he co-founded a company that developed an optical component for fiber optic networks. It got sold to Cisco Systems, which worked out pretty well. And he got very interested in this solar energy solution. It was proposed by somebody who was concerned about the conditions that many people live in around the world, where in places like India or the developing world, where they don't have ready access to affordable fuels, and they're basically burning biomass in their homes, spending many hours a day collecting wood, other biomass, and then burning it in their homes, which has negative health impacts. And she was looking for, is there a solution out there, a sustainable energy solution that could one day be sort of deployed in these places and provide a low-cost source of energy? So the design was kind of originally inspired by that problem. What's a solution that could be provided, that could be a renewable energy solution that could be manufactured locally in those countries with the technical skill capacity that exists in those parts of the world. So it's actually, our device is actually kind of a low-tech solution in some ways. It's made of all steel and a skin of aluminum on the reflector. It uses casting and stamping processes for the production. So we're not using semiconductor advanced manufacturing here. It's relatively low tech from a manufacturing point of view, which means it's something that could be easily supported in terms of manufacturing in places like India or other countries that have that kind of in-country capability. And then the other thing is, in terms of maintenance, no special equipment is needed. It can be maintained with simple tools and a ladder, basically. So it's easy to support in the country. So those were some of the design criteria that went into this. It was then realized that to really scale this up, we would need to commercialize it. It's the only way to get the volumes up and get the price down where people can actually use it. So then a company was formed, and we're looking to find commercial users in industry and other applications.
Does this have a plug? Does it require, being plugged into a wall socket to operate?
Yeah, there's some electrical power that's required to operate the tracking mechanism and the sensor suite that monitors the performance. We're going to install some photovoltaic cells on the dish so that it will have onboard autonomous power. We're trying to minimize the amount of work that goes into installation. We want it to be kind of a turnkey solution. It's out of the box, bit like IKEA furniture. It just sort of snaps together and then it runs. Yeah.
The reason I ask is because certainly one of the continents that's behind the curve energy-wise, but ahead of the curve sun-wise is Africa.
Yes.
And anything that can be easily implanted into that continent to help it develop would be a big, big win. And I suspect you've looked at this as well.
100%. That's just the kind of scenario that was that inspiration for the original product. And we definitely see a lot of opportunities for this in Africa, and would love to get it in use over there once we're fully in production. We've had a lot of inquiries from Africa about technology as we've been promoting it. There's many countries in Africa where it would work extremely well, particularly in South Africa, in Namibia, where you've got tremendous amounts of direct irradiance or clear skies per year. Yes, it would be a great use case.
So what is the size of this, both in footprint and length, width, height?
Yeah, it's fairly large. There's two versions. One has about a 4.5 meter diameter, the dish itself, and it's 14 meters squared aperture. So the dish area is about 14 meters squared. So that's the smaller dish, and then it requires a bit of a clearance area. We want to make sure that in the event that the dish is not aligned with the sun, that the focal point is not going to burn somebody or have some safety problem. So we like to have a clearance area around it for safety purposes. And then so we probably need about 27 square meters for the smaller dish in terms of footprint. And then the larger dish is much bigger. Basically, we have one version which has a single inner ring of petals. There's about 20 petals, which are individual panels of reflector. And then the larger dish has a secondary outer ring of petals, another 20 petals running around the inner ring. And that's 3 times the area. So about 42 meters of aperture. And that'll require, that's about a 7 meter diameter in terms of the dish. So pretty big. And it'll require about 80 meters of clearance per unit. Yeah. Okay.
Well, it's not like I need 10 football fields to make that happen. So that's very encouraging.
Yeah. So we like it because it's a very modular and scalable solution, which means it can be flexibly deployed based on the client's needs in a fairly incremental way. Unlike some of the other concentrating solar power solutions like power towers, the minimum scale for our device is fairly low. I mean, you could put 1 device if you need to, or you can have 5, or you can have 100. It depends on how much space you have, what your power requirements are. So it also sits on a mast, so it doesn't actually take up that much ground. You could potentially grow things underneath it, for example, or have landscaping, or who knows. It might get burned on occasion if something goes wrong, but that's not too much of a problem when it's vegetation. But yeah, it sits on a mast, so it also doesn't require a lot of land preparation. You could put it on unprepared ground. You don't need to level the ground. You just put the mast down, a bit like a telephone pole. You could pile drive that telephone pole in, just like that. You can do the same with the mast here and mount the tracking mechanism on top, dish on top, and then it'll self-calibrate and off to the races.
Now, certainly one of the concerns with something of this shape and size is wind, particularly the durability of the mast and its ability to absorb the pressure of that wind. I know that you've taken that into account.
Yeah, that's a key consideration. That's something that we analyze heavily in the design. So we've done, a full FEA analysis on wind stresses and where the wind stresses kind of are concentrated and what the resistance of the device to various wind speeds should be. The bigger dish will operate up to 30-mile-an-hour winds, and then it goes into a safe mode automatically. So it has a wind sensor on the dish, and it'll detect what the wind speed is, and it'll go into what we call the safe mode, which is the receiver pointing up at the sky. So it minimizes the profile to the wind and minimizes the wind stress, and it'll resist wind up to about 100 miles an hour. So certainly these are sort of industry standard benchmarks. So we designed it for that. Now you can definitely design for higher wind stress, but then your cost will just go up. So we're trying to get the sweet spot of keeping the cost, moderate, and also having sufficient wind resistance to account for most conditions. And then the smaller one is actually very wind resistant. Obviously, the wind goes up sort of exponentially with the area. So when you divide the area by 3, you get vastly higher wind resistance. So we're looking at potentially operating up to 100 miles an hour and resistance far higher than that. So it'll depend on the situation. If you're installing in a hurricane zone, for example, you'll need to really optimize for wind resistance. If you're installing in areas that don't often see high winds, then you might go for be willing to accept more risk on the wind resistance.
Well, I'm glad you calculated in that it doesn't melt things like the high rise in Las Vegas, where they didn't exactly compute that in, and it was melting cars. Yes.
Yeah. I think there was a story about a building in London as well, where it was a curved glass building, and it was sort of it was effectively functioning as a solar concentrator.
That's right.
Yeah.
So for the sake of our viewers and listeners, a couple of things I'd like you to share with them. Number one, because your first name is unusual,
yes.
How to pronounce it, and the location of your website.
Yeah, sure. So my name is nee'sha, Naoise. It's one of those Irish Gaelic names, pronounced nee'sha, and then Irwin, my second name. And then the website is www.solarflux, SOLARFLUX.co. So not .com. We don't have the .com yet. .co. Yeah.
Great. nee'sha, if there is a case study that you would like to share as we wrap this segment up, I'd love to hear it, because I think this is fabulous technology. I love to see anything that utilizes the sun's energy. I said for decades, what are we doing with that thing, and why aren't we doing more?
I know it's an incredible resource. 1,000 watts per meter squared every day is reaching us. Yes. So as far as the case study goes, so we have a unit that we've been running for a long time at Penn State campus here in Pennsylvania, where we're developing the technology. We've got great data. I mean, I'm hoping to write a blog post doing a 12-month retrospective on the operation of that device shortly. But we've got great data coming off of that device. We've demonstrated using a sort of an industry standard test method, which the data was then independently reviewed, and the methods as well. 72% solar to thermal performance, which is really good for our test unit, like what we have, and we expect that to go up as we get to production, because we're going to have a much more precise curvature on the dish, which should boost the concentration ratio and the conversion efficiency. So we expect to get into the mid 70s potentially with solar to thermal conversion performance, and this is with nothing more sophisticated than pure aluminum. So it's a fairly simple material. So we're really excited about having gotten that result in terms of performance. If you look back over the past 12 months, how has it performed? That is the performance that we're getting on an annual average basis, so we're getting about 70 to 75% conversion overall, which is very good. And that is actually, the parabolic dish is known to be the most efficient solar energy technology. And that's because it's always tracking the sun. It's always perfectly aligned with the sun. It's directly normal to the sun. You're taking full advantage of the aperture at all times. And that's not the case with other technologies. For example, parabolic trough, when the sun, in the winter months, when the sun's lower in the sky, that causes the effective aperture of the trough to be lower. So it'll actually reduce the efficiency on a per meter squared basis in terms of conversion. So you'll probably get, 55% on an annual average basis for a trough, maybe 40 to 45% for a power tower. But with parabolic dish, you can get up to 70, 75% on an annual average basis. So it becomes, and this is a per meter squared equivalent. So like for like. So we think it's a super efficient technology. Our data has supported that and validates that, and we'll be sharing more on that soon. And in terms of the use case there, so it's a test installation where we're injecting the heat into a greenhouse. So we're providing space heating in that case. It's a direct offset to natural gas. So the greenhouse at night uses natural gas heaters, and then we have a storage tank that will inject heat when available to offset the consumption of the natural gas. And that's an application that we see a lot of opportunity for here in the region, even in Pennsylvania, which isn't the sunniest place in the world, but we think there's a good amount of there's a lot of greenhouses and a lot of opportunity to even provide solar heat in this area, despite that.
Well, yeah, greenhouses are a great application, and this is something that, again, to bring in that continent, Africa is looking at, is how do we get an energy source so that we can grow crops and feed our populace. So I think that's a terrific application for you to test. As a matter of fact, just to remind our listeners and viewers, every month we publish a magazine called Manufacturing Outlook. And one of the sections is called Technology Outlook. And I would like to invite Solarflux, if you have a spare 1,500 words, to submit it to us. We would love to publish it on this technology.
That would be amazing. We would love to do that.
Great.
We'll certainly follow up with you on that.
Excellent. Well, we look forward to that. nee'sha, I really appreciate you being on Manufacturing Talk Radio with us and representing Solarflux. I love the technology. I love anything that utilizes the sun's energy. Folks who know me know I'm big into graphene, because someday I see that as flat panel glass in high-rise buildings. The energy grid won't be happy, but it'll be very green. This is another great green technology. Thanks for joining us.
Thank you so much for having me on.
And so we will put this up on our website. We will also get an article from nee'sha on Solarflux, and we will continue to promote this brilliant technology. Thanks for joining us, nee'sha.
Thank you very much. Talk to you soon.
And thanks everyone for listening to this episode of Manufacturing Talk Radio.